Welcome members to today's lesson. Today we are going to see integration. But please, before we proceed, first subscribe to the channel by pressing that red button, subscribe. Now, if you have f of x equal to x squared, and now how you interpret this is, if you have x power n, all you do, you get this power, you increase it by 1, so you add 1 over the new power. This one now is the new power. The old power was n, but when you add 1, you get n plus 1 divided by the new power, which is n plus 1. Then plus a constant of integration. This one is called the arbitrary constant or constant of integration. Why? Because whenever we have definite integrals, we put a constant of integration. Definite integrals are integrals without limits. Now, when you come to the next one, this one is called a definite integral. Why? Because it has limits. These are what we call the limits. This one is called the lower limit, and this one is called the upper limit. So, assuming that when I interpret small f of x, I get capital F of x. Now, these ones, for them, we evaluate them. You substitute in this function, you substitute in the upper limit, minus in the same function that we have got after interpreting, you substitute in the lower limit. Now, when we have integral of a constant, it's as simple as multiplying x or multiplying the variable in that constant. How do you know that? You know that here there is x power 1. So I mean x power 0, which is 1. So when you increase this power by 1, you get this over 0 plus 1. That's why you have x. Now that is this constant of integration. This k is a real number. It can be a fraction, it can be negative, it can be a positive. In examples, we have integrate the following. Now, so the x here we have is x power 3. So to interpret this, you increase this by 1, divide by the new power. So this one will be adding. So increase it by 1. Now start this one, you don't have limits. So this will be x power 4 over 4, then plus a constant of integration. So if you don't have limits, you put this arbitrary constant. In example 2, you start this one as x power 1. If it's x power 1, so it will be 4 into x1 plus 1 over 1 plus 1, which will be 4x squared over 2, and you see this 2 goes there, so it should be adding 2x squared. But because we don't have limits, I put a constant of integration. You see this one now, it's just the x integrate, but you saw this one, there is a constant, there is a k. Our k this time is 1. So all you do, this will be the same as 1 times x, which is x. Without limits, we put a constant. Why? Because you know that 1 is the same as x power 0, because the variable is x. So you increase this by 1, divided by 0 plus 1, shall be adding x over 1. That's why we are adding x. If we add a constant which is different from 2, we multiply there by 2. Now, when we come to this, that is a variable of t. So we have to first push this one up in the numerator. So shall be adding now integral of t. When I push this up, it becomes -4. Because indices d, now this one is the t. The idea is the same. This will be now t, the power, we increase it by 1, we divide by the new power, which will be now t, -3, when you add this with -3 over -3. So plus a constant of integration. Why? We don't have limits. Now the first 4 are indefinite integrals. They never had limits. That's why we have the constants of integration everywhere. But when we come to this, is that we have the limits. The lower limit is 0, the upper limit is a 1. We are going to see. Now we start this one, we have the more than 2 terms. It's okay. You just apply the same idea. So this one is x power 1, so we have in 2. Then when I increase this power by 1, you see this one is 1. When I increase 1 plus 1, I'll be adding x power 2 over the new power now is 2. Then plus 4 is a constant, so it's a constant here. So this is what we get for. It's that here there is x power 0. So x. Then this one we have limits from 0 to 1. So now we see these two and these two they go. So we'll be having x squared plus 4x from 0 to 1. Now we start substituting the upper limit first. These ones we evaluate them. So this will be the upper limit. When I put here 1, I'll be having 1 squared, then plus 4 into this one here. Then we subtract off when we put in the lower limit. So the lower limit is, when I put here 0 squared, I'll be having 0 squared plus 4 into 0. That's how we evaluate this. This is 1 plus 4, it will be given as a 5. Then a 5 minus 0 remains 5. When now I come to this will be, you see that this one is a constant, so when I incorporate a constant, I'll be adding 2x. Then this one will be, I increase the power by 1, so this one is power 1, when I increase by 1 I get x squared over the new power which is 2. And it also has limits from negative 1 to 1. So how we evaluate these limits, you know now we shall be saying integral of, we put in the upper, when I put here the upper, I'll be adding 2 minus, when I square negative, and when I square 1 I get 1, so 1 over 2. Then I subtract off when I put in the lower limit. The lower limit is negative 1. When I put here negative 1, I say negative 1 times 2, I'll be adding negative 2. When I put here negative 1 squared is 1 minus, I may have minus a half. Then the answer here we get is 2 minus a half, we get 3 over 2. So here we have 3 over 2. Then minus, when you subtract this, you see that this will give us negative 5 over 2. But this negative 5 over 2 and this negative, so it becomes plus 5 over 2. So the LCM is 2, when you add, you'll be getting 8 divided by 2, the answer will be a 4. When you come to this thing, you start with a definite integral because it has limits. We said when you have this, you first take them up. This will be now integral of x negative 3 dx. So we say you add here 1. When I add here 1, I get x negative 2. Then this negative 2, you divide it there. Then from 1 to 2. This will be now, when I substitute a 2, I'll be having this as, okay, before we do this, we can see that we can simplify this with ease. So this will be the same as 1 over negative 2. So this x, when it goes down, becomes x squared, but from 1 to 2. When I put this negative down, becomes a positive, there is only negative 2 here. Now, when I put in this 2, when you put in the upper limit, I'll be having half negative into 2 squared, then minus in brackets when I put in the lower limit. So I'll be having 1 over negative 2 into, now where there is x is where I put the limit. So I'll be having 1 squared, then I cross. This will be, you see this will be a 4 times this, I'll be having negative 1 over 8. Now minus 1, so you have minus this 1 squared is 1 times this negative 2, so this negative goes up, so it will give me negative a half. And simplify, so this will be a positive, I'll be having negative 1 over 8 plus a half. When you simplify that, you start to be having, this will be negative 2 plus 86 over 16, which can be the same as 3 over 8. So now, finally, when you come to this, you see that this one is an integral still in a polynomial form. So how we do it is exactly the same way. So this will be now, you see here, I increase the power by 1, so I'll be having 3. X, when I increase this power by 1, is power 2, plus 1, I'll be getting 3. Then I divide this power by 3. Then minus 6 is a constant, so when I increase this one by 1, I'll be having x squared, then I divide by this power, which is 2, minus this one is a constant. When I interpret a constant, you get 3x. Then this one is from negative 1 to 2. Okay, that's simplified. It's that this is 3, cancels with this. By this one, by this is 3. So I have x cubed minus this cancels with that to get 3x squared minus 3x. We have limits from negative 1 to 2. So let us substitute in the upper limit first. When I substitute 2 here, I'll be adding now 2 cubed minus 3 2 squared minus, where this x is where we put the limit. So that's why I have this and this 2. Then the whole of this we are subtracting off when we put in the lower limit. So we have negative 1 where it is x. So negative 1 cubed minus 3 into negative 1 squared minus 3 into negative 1. The whole cross it now. Let us see. This will be 8. So I have 8. This will be 4. This will be 4 times negative 3, that's negative 4. 8 minus 4, that's negative 4. Minus 6, that is negative 10. Then minus into, when you put a negative, we get a negative. So here I have negative 1. This is positive 1 times negative, so that's negative 4. Plus the 3, plus the 3, that gives me negative 1. And this will be now negative 10 plus 1, and the integral becomes negative 9. So that's the difference when we have the limits and then when we don't have the limits. These ones without limits are called indefinite, and we put a constant of integration. These ones with limits are called definite integrals, and we evaluate them. For them, we evaluate them and we have specific answers. So we have, for them, we have answers. These ones, we don't evaluate them. So don't forget to subscribe to the channel. I wish you the best.